So it turns out that the user manual for this leak amplifier is wrong. It says that the pin numbers shown on the diagram are for the bottom of the socket. Well, when I look at this socket, and I have this connected directly to the preamp just so I could line up the pins, I find that they're backwards. The pin 6 on the socket is empty, as it says on the schematic, yet on this side, pin 6 has a wire going to it. On this side, pin, what is that, pin 2, pin 1, pin 1 is ground. On this side, pin 1 is the signal out. So when I hooked this thing up, I got a horrifically loud buzz, and that's because the ground, the entire case of this thing is ground, and that was going straight into the signal input on this side. So it was really, really bad. So don't trust the leak schematic in the manual. Just hold the wires up to the thing here and make sure you got it right. So now I got to rewire the inside of the amp here, because I've got the mirror image basically of what's on this socket. So I got to flip every wire from one side of it to the other side. That should fix the problem. Then hopefully we'll be able to test out the preamp, because I'm eager to see if it's still working right. So just turned on the amplifier here. Got it hooked up to the leak preamp. Waiting for the tubes to warm up. We'll see how it goes. So here's some hum. So something's working here, so let's turn the volume up. And that's lovely. That's just lovely. It's on tape input. Let's see. The hum doesn't change with tone or anything, so that means it's before the tone stage. Changes with the volume. Changes. Actually, it doesn't change with any of the inputs, just noise from the inputs. So, let's see. Wonder if it just needs a ground. Maybe that's all we need. Let's do some experimentation. Also, let's check the bottom here. Let's see. Lo and behold, there is an electrolytic capacitor here. Might be bad, so I'm going to go ahead and change that. I believe the rest of these... Oh, that one's electrolytic too, and so is that one. Those are low voltage though. It says 12 volts. Here's two more down here. So, we'll probably have to replace those 5 capacitors. This light bulb is burned out. That's going to be tough to replace. Might use an LED maybe. We shall see. Cute. Turns out this bulb is not burned out, it's just loose. Alright, so I don't even have to worry about replacing that. Sweet. Okay, I've replaced the electrolytic capacitor here. I pulled out these old electrolytic caps here from 1958, and I've put in new electrolytic with 0.1 microfarad bypass. These are 47 microfarad, 25 volt, and 0.1 microfarad. So I've put one of those combinations here at each of the junctions that bypass the cathodes on the tubes for higher gain. I'm also going to use a file, which I had here a minute ago, and file down around the screw head here through the paint, and then I'm going to put some of this special conductive tape on there to make it just a little bit of a raised bump there, so that when we put the lid on, we'll have positive electrical contact to help shield that on both sides, the top and the bottom, because they both have the same issue there. let's see. I've got the contact cleaner that I sprayed inside these switches, so hopefully that'll help get rid of some of the pop between when you're switching from one setting to the other. And then we'll try it out and see how it goes. But the major thing was definitely the grounding. That was a huge problem. So that is the key. At the last minute, I decided to throw an extra 0.7 microfarad 400 volt metal foil cap across the 8 microfarad power supply cap, which is actually 22 microfarads now. So hopefully we're killing hum and noise on both ends. I was able to scrape the paint off here and then put this conductive tape down. I verified it does conduct, and then I also scraped this part here, so now when this goes on, we've got definite electrical contact right at that point there. Put the screws on, and it is about as good, well sealed as it can possibly be. So we're going to do the same thing to the other side. Okay, since this preamp has original Mullard tubes in it, I'd like to save them. These are all EF86s, and this is my Heathkit TC3 tube checker, and the equivalent number for EF86 is a 6267. So that means we switch this to type 1, 6.3 volts the filament, 20 on the plate, and A, F, H, J, C, E. Go to the bottom. Go ahead and drop this guy in the socket and turn it on. Right there. Wait for the tube to warm up. But it's showing 80, low 80s percentage there for that guy. So let's pop this one out, put the next one in. Alright, well, all 4 Mullard EF86s in there tested at the sort of low 80s percentage, which they still work fine, so we'll leave them in there. They all match really well, which is great. Since I saw firsthand how important the shielding is, I wrapped a copper tape around my Octal cable here that I made up, and I attached the shield of the cable and also the ground to the socket, also to this shield, and I'm going to go ahead and wrap that in some more of this rubber tape to give it some protection from the elements. I'll do the same to the other side as well. Well, there we go, bloke. We've got the 0.1 stereo up and running. I don't know if that's an Irish accent or a British one, but there we go. So power's coming from the amp, goes to the 0.1, and apparently that work paid off because the volume is now 5 or 6, and the noise is quite low. So I'm quite happy with this now. So there we go, bringing the leak guy back to life with a bunch of caps and a bunch of rebuild stuff here. We still have to get that 3-prong power cable hooked up. That shouldn't be any trouble. And I still don't know why this runs on 230 volts, but it has 115 volt plugs on the back. That's a mystery that I'll probably never solve. There's a spare fuse. But there you go, beautiful leak amp, beautiful leak preamp.